So, expecting the others still coming in, we'll continue with the revision session of the last class. Okay, so while others comes in, we'll be continuing with the review session. So what we saw in the last class is, what we discussed in the last class is, discussed about the corresponding multiple accessing schemes which are helpful for the what is called as Mac. How it is going to be using different multiple accessing schemes in terms of Mac execution, that is sending the interface in between the physical layer and the corresponding LLC layer of the data link layer, how it has been communicating with, what it has been interfacing. So, and depending upon the environment and depending upon the mobile communication paradigm it has been working with, it is going to choosing the corresponding accessing schemes. So we have saw the what is called as SDMA is space division multiple accessing, frequency division multiple accessing, and we are seeing the versions of TDMA, that is the time division multiple accessing. Okay, so we have seen various versions, and we will go through the particular versions of this TDMA. So we discussed about fixed TDM and how it has been working with time division multiplexing. And also we saw the different disadvantages regarding with fixed time intervals allocated to the fixed stations and the fixed uses. So we are going to working with the corresponding dynamic oriented TDMA schemes. That is, depending upon the request of the users, you are going to follow with the accessing of the corresponding channels for transmission of our data. Right, among the particular dynamic oriented schemes, the classical Aloha is the one where users are freely moving over the transmission media to transmit their data, whereas they are going to have the collision procedure. But the collision thing, that is the consequences of the collisions are being left to the higher layers in order to rectify them. That has been left to the higher layers, right? They has to request a particular senders for the retransmission of the data, or if there is any error in a data that is being received. That is about the classical Aloha. And coming to the refinement of this particular classical Aloha, we have the slotted Aloha, in which the sender and the receiver are being synchronized by what is called as slotting or slicing the total available transmission period into the different time slots. Whereas the senders are being instructed and they are being suggested to send the data at the starting of the slot itself. Even though it is being done as a modification for the classical Aloha, it has not been an advantage. Why? Because even though the corresponding time slot has been given, but it's not given to the senders, it's being given for the transmission period. So because of that also, there will be a chance of having the collisions, right? That is about the slotted Aloha. But when compared to the throughput of the classical Aloha, the slotted Aloha has got the double of it, but not the completely. Only 36% of the throughput has been achieved by the slotted Aloha, right? It has been perfectly, well implemented for the light load systems. Right way do we doesn't consider about the throughput. And coming to the carrier sense multiple access, this particular carrier sense multiple access is the one basic improvement with the basic Aloha, where you are being sensing the carrier, identifying that particular transmission medium is busy with a particular carrier transmission, and they have been waiting for. In that cases, we are having different cases. That is one persistent CSMA, what is called as a non-persistent CSMA and P-persistent CSMA, and also CSMA, CA and CSMA CD are all the different versions we have. In the one persistent CSMA, the station which wants to send the data will be what is called as sensing the carrier for the bandwidth at that moment, and whenever the carrier is used to be working in that particular transmission media, then it is going to be waiting for a particular interval of time until the carrier gets free. Then only it is going to be sending the data. That is called as one persistent CSMA. And coming to the non-persistent CSMA, in that case, the station which is willing to send the data to the transmission medium will be sensing that particular transmission medium is having some carrier frequency, carrying some data by some other station. It will be waiting for only for a random amount of time. Then after the random amount of time has been expires, then it is going to be repetitively sensing the medium for sending the data through that particular carrier. Okay, so that no specific time interval and no specific waiting of the station will be done. Randomly it will be checking that particular busyness of the carrier. that coming with the P-persistent CSMA. But because of this particular, what is called as non-persistent CSMA, the station shouldn't be remain idle, but also the carrier shouldn't be remain idle. Both are going to be working, but no service is going to be get obtained by the non-persistent CSMA, even though the other station doesn't want to send the data through that particular channel at that moment, in the case of non-persistent CMA or one persistent CMA. CSMA. And coming to the P-persistent CSMA, here the transmission channel is going to be shared among multiple number of mobile stations in the available slot of time itself. In the available time slot itself, all the what is called number of users are being given allocation or the sharing of the time interval. How it has been done is been discussed in the last class. That is nothing but a random time amount will be given for the each and every station to be waiting for to get the access of the carrier. But they are going to be checking that whether the time period of waiting of themselves is being compared with each and every time, that is with the assessment period of the particular station sending the data packet in the next time slot immediately. If that particular time period of sending the data by the station in the next time slot is going to be very greater when compared to the random time amount of waiting, then obviously our station will be getting into the scene and it is going to be sending the data that is called as P-persistent. That is probability of sending the other station a particular packet of data through that particular station, through that particular carrier is being assessed and it is being assumed. According to that, our random period of waiting is going to be get compared. Whenever our random period is very lower when compared to the next time slot to be get started by the other station, then our station will get into scene and it will be transmitting the data. So after transmitting, again it comes back, right? So in that way, number of stations are going to be sharing the carrier. Okay, so and giving the access, that is maximum efficiency or maximum throughput can be drawn through that particular P-persistent CSMA, right? Another scheme also is there for us, CSMA with collision avoidance, within which we are going to use this particular scheme in the wireless LANs itself. Here it is going to be providing you the avoidance of the collision, that is with the previous scheme that we discussed in the first unit, that is CSMA with the CD, that is collision detection. We are sensing the carrier and we are going to be detecting the collision after transmission started by the channels. But here what you are going to do before the transmission started by the channels, our system is going to be avoiding the collisions if any comes in. That is, you are being assessing that if there is any chance of coming collision by the to be transmitting channels, then you are going to be avoiding particular transmissions. What you are doing is you are going to be setting up some alternative schemes and backup schemes in order to provide the transmission of those stations which are going to get collided with each other. So that in that way we are avoiding the collision and at the same time we are going to giving the throughput and efficiency in increased manner. Right. This is how you've been discussed about one persistent CSMA and P-persistent CSMA. In one persistent CSMA, only we are being waiting for a particular amount of time, otherwise we are being transmitting. But in the P-persistent CSMA, we are waiting for a particular slot and also you are going to be checking, for example, if it is not busy, then you are going to be checking that X is going to be a random amount of time that is to be waited by us, and it will be checked and it will be checked against with the probability of that particular station, that is the previous station, willing to send the next data slot through that particular carrier. So if our random amount of bit of amount of waiting time is being very less when compared to the probability of that station sending the data through that particular carrier, then you are going to transmitting our information. Otherwise, you have to wait, obviously. So this is what happens with the P-persistent CSMA. There is nothing but we have to calculate the probability of the other neighboring stations or the stations which are sharing our carrier, right? And coming to the DAMA, which has already been discussed in the last class, which is going to giving you the 80% of efficiency or the throughput when compared to the classical aloha and the slotted aloha. So what it is doing is it is going to be providing you some reservation mechanism when compared to the other things, that is demand, assign, multiple access. So as the schemes that you are been discussing, the name has been directly given to the scheme, that is demand, assign, multiple access. According to the demand itself, the accessing will be given to the multiple subscribers. So what you are doing is the user itself, he is going to be what is called as reserving some slots by himself. Okay, once he has been on the line for transmitting the data, he is going to be having the chance of what is called reserving some slots to transfer the future information, right? But whenever these are going to be having the chance of the collision, because of some exposure and hidden terminals. That is because we are not known with unknown information. That is, somebody are going to be using the same time of interval. That is, somebody are going to be parallelly reserving that particular slots. There may be chance of getting the collisions. So instead of that, or rather than that particular collisions, we will have some efficiency improvement. That is, up to 80% we can implement this particular reservation mechanisms but using this particular Dharma, right? Okay, so that particular Dharma can also be called as reservation aloha, as it is been implementing the reservation mechanism. Each end user is going to be doing reservation of his future slots. So, and this has already been discussed, that which is very similar to the pooling procedure in the operating system. Whenever you are going to be implementing the paging procedure, that is, whenever we are not available with the required pages in the corresponding memory, then all the requests which are being asking for the free pages to be available in the main memory, then the pages are going to be get pooled at some place. So that pages requests are going to be get served by the operating system by swapping over that particular pages request whenever there is available free slot in the memory. In that case itself, here also, whenever there is a free slot, then it will be get allocated. That is what happened with the demand assigned multiple access, right? So this is what we have done. We are going to be using the unused slots, and they are being get pulled up and they will be used. In these cases also, there may be chance of having the collisions whenever we are unknown about that. All are going to be parallelly reserving the same slots of information or same slots of time. Sorry. So in that cases, there may be a chance of having the what is called as collision. And this particular pooling procedure of this satellite channels, as you're going to be using the satellite as a medium for communicating the information through the electromagnetic radiation, this particular pooling procedure is going to be implemented as a group, not only the single paging. See, in the pooling procedure, you're going to be implementing the page request as a single page. Each and every page which is going to be missing its availability in the main memory will be given access to the particular page in the main memory to be available. We are going to implementing the swapping procedure in a single page manner. But here, the data traffic and the data value and the data channels are going to be communicating in a batch mode, not as a single user or a single data to be transmitted. Group of data or the batch of data is going to be driven, right? So that is about the Dharma. Next one is PRMA. So what is this PRMA? This is nothing but the packet reservation multiple access. So within this previous case, we are going to be reserving the slots, right? We are reserving the slots of the transmission actually. That is the explicit reservation procedure. But what happens here is, within the packet reservation multiple access, what we already discussed in the previous class, what happens here is, within the existing GSM TDMA frame, the slots are going to be booked by the corresponding stations. That is, for a single packet of transfer, they are going to be choosing up that particular slot. Instead of the transmission slots, you are going to be accessing the packet slots in a single frame. That is, in a GSM TDMA frame, that we know that it is being divided into 8 radio carriers. Among that particular 8 radio carriers, 8 stations are having the possibility to reserve that 8 slots to send their data through the channels, right? So in the group itself, using the same frame itself, you are sending 8 packets by 8 stations. Isn't very efficient when compared to the other things? See, each and every channel is being getting competed by in all the other previous schemes that we've been discussed, right? They are being reserving the slots, they are reserving the channels, they are reserving the frequency bands, they are reserving the time intervals and all those things. But what happens here is, within the single radio channel itself, within the time division slot itself, total 8 slots of the TDMA frame is going to be get allocated for the 8 users, so that it can assume that how so much of number of subscribers can be accommodated to send the data in a multiple fashion, right? So this is the implicit reservation procedure. So already we discussed about this, how this particular 8 slotted TDMA frame will be get allocated for the 8 stations. See here, this particular frame with 8 slots has been allocated for the 8 stations. Maybe they are going to be repeating, but they are going to be sending the 8 information through the 8 channels or the 8 slots. So that in this case, 7 is being free. That is at the first attempt, the frame is being free for the 7th slot. So for this particular frame, which are in need of the particular slot from the TDMA frame, all the stations are going to be trying to get that particular free slot. Okay. So 7 is being free for the first attempt. 7 is free, that is the 7th slot is free, then all other stations will try to get that particular free slot to send their packet of data in that. In this example, already we discussed that multiple stations have been trying to get the access of 7. In that particular multiple battle of getting the free slot of that particular 7th station, only the F has been succeeded, all are being get collided. F has been succeeded, all are being get collided. Whereas we have been shown like this, the T is going to be get collided with the 7th slot. Okay, 7th slot. So, but whereas who has been succeeded? F has been succeeded. In that case, we are going to be reserving the packet size, that is a packet slots within the TDMA frame itself. Okay, this is the implicit packet reservation. We can do this by saying the status itself. All other stations are going to try to get the slots in order to send the information through them, right? And coming to another procedure completely named as reservation TDMA, in which instead of a time intervals or a time channels, or maybe the what is called as time slots, or maybe the frame slots, not all these things, among the total available time slots of transmission, we are going to have the chance of reserving some set of numbers of slots for our transmission in this reservation TDMA. What you are going to do, we are going to have, the user is having the chance of reserving a certain number of slots for its own transmission of the data. He's going to be reserving that particular slots, and those slots are called as the mini slots. So according to the number of what is called as which channel that is going to be reserving, that particular channel number will be given, that is called as n is equal to 6. That is nothing but the total number of slots that is being booked by the channel is 6, and k is equal to 2 is the total number of data slots. That is, in 6 slots of that particular channel reservation, each and every slot is going to carrying 2 data slots. Okay, so each and every slot is going to be carrying 2 data modules along with it. So that once n mini slots has been inserted by any station, they will be get expanded like this. That is 6 into 2. 12 slots are available for sending our data. So if these slots, any one of these slots are not being used by our station at any time interval, they can be chosen by other stations which are in need. Okay, they can be chosen by the other stations which are in need. Okay, so this can be done, which can be implemented in round robin fashion. Using that particular round robin fashion itself, how you are going to be what is called as sharing the time available. That is, a burst cycle is going to be shared among all the particular jobs that are being in the scheduled ring or a scheduled cycle. In the similar way, here also the jobs which are being idle, the slots which are being idle, which are already reserved by some job or some user, can be used by the users who are in need at that moment if there is a probability of not using by the owner of that particular slot. Okay, so these 6 slots are being owned by some station, but if they are not usable, or if they are unused at that particular moment, then the other stations can use that particular data slots without disturbing the owner. Okay, so this is about the reservation TDM, right? Because of this, we are going to have the much of throughput and also maximum of the bandwidth can be available. Why? Because similar to the previous case, that is, most of the users can be transmitting within the available slots. Most of the users are going to be transmitting the data with the available slot. That is, unused slots of the existing owners will be used by the required users. So in that way, bandwidth can be maintained, and also the occupancy. There is nothing but most of the users can be accommodating within the available bandwidth, right? And coming to this, mobile access with collision avoidance, another procedure. Multiple access with collision avoidance. See, especially this particular procedure has been meant for avoiding your problem that is already with the particular Csma procedure, what you've been discussed with the actual problems of the Mac implementation, that is the wireless procedures. Wireless mobiles are going to be having the problems of hidden and exposed terminals, right? Hidden and exposed terminals and near and far terminals. So to avoid that particular problems, which are very severe in case of wireless LANs, as we already discussed, okay, So to avoid that particular main problem, you are going to implementing this multiple access with collision avoidance. So what in this case, first we'll consider about the hidden terminals. Already we discussed about that A is going to be hidden by C and C is going to be hidden by A, isn't it or not? A is going to be feasible to B and B is going to be feasible with A. They are going to be transmitting with each other, whereas C is not heard by A and A is not going to be heard by C as they are being parted with a larger distance, right? So in that case, obviously A and C are becoming the hidden terminals and they are not going to be getting the actual information that they want to get transmitted. Right, and because of which B is going to be get collided with each other. That is, A's transmission will not be get known by the C, and C's transmission will not be get known by the A, which is been which of which two are going to be communicating with a common user, that is the B user. There comes the collision part actually. Okay, so A is being collided with C with the transmission of both of them with the B in common. So in that case, how to avoid that particular collision avoidance? We have to have the multiple access, but we have to avoid the collision. So what we are going to do is, in this case, that is, whenever A wants to send the data to B, it is going to be sending a peculiar signal called as RTS. That is nothing but the request to send. Already you know about these signals. I think every communication partner and communication links will have these type of acknowledgements, right? Signaling alerts and the acknowledgements will be there for us. In this case, A is going to be sending the request to send signal to the B station, implying both the sender and the receiver addresses in that particular, implying both the sender and receiver addresses. So when it is being received by the B terminal, B has to give a clearance of the particular channel. Okay, clearance of the particular channel to receive the data from the A. Okay, so that is will be sent in return to the as an acknowledgement to the RTS. That is as CTS, clear to send. Clear to send information will be sent to the A in return. So, but here, ma'am, the CTS is also been sent to the C. What is happening here? So the CTS has to be sent to the A from B side, as it has been received the request from the A to send the information from A side to the B side. But here the B has to send the CTS to the A. But what happens here? It is also sending the CTS, the same CTS to the C also. So what it has been implying is the CTS which has been received by the or sent to the C also contains the data that is being sent by the B to the A. That is nothing but B is now busy while getting the information from A. B is now busy while getting the information from the A. That same information will be conveyed to the C as CTS. C as CTS. Then only the C can identify that A is not available to it, and sorry, A is in hidden position, or also A is in transferring the information to the B, and B is in busy position, so that it couldn't get communicated with the B at moment. So that is the thing, that is the idea behind this particular procedure, to avoid the collision by also avoiding the hidden terminals. So that even though A is being hidden with C and C is being hidden with A, by using this particular handshaking signals like RTS and the CTS, which are going to be true and fro communicating signals in between these stations, we can avoid the collision. So that B is not going to be collided with the transmission in return with the C, has already been communicating with the A, right? A is going to be sending the request to send the signal, and B is clearing its channel to send the information, and the same information is also been sending to the C, intimating that it is being busy in getting the information from the A. In that way, you are going to be what is called as clearing the what is called as hidden terminals, and also avoiding the collision, right? And coming to the what is called as exposed terminals. So again, we are having some range, that is what is called as, we are going to be having some exposure of the B with the C. That is, if C wants to send the information some other to terminal, which is not with A and B, it's not been considering with A and B, but wants to send with some information to somebody. Okay, but by sensing some carrier which is very nearer with B, it is going to be unnecessarily waiting. Okay, which is because of the exposed terminals. C has been very exposed with the, C has been very exposed with the B terminal, which is very nearer in that case, where we have been discussed about the exposed terminal. C has been exposed to B. So that's why by sensing the carrier which has been communicating by B, it is C is going to be remaining idle, even though it doesn't want to communicate with A and B. in that case, what we are doing is B wants to communicate with the A. B wants to communicate with the A in this scenario, so that B and A are been communicating with each other. But C doesn't want to communicate with either A or either B, but wants to communicate with somebody. But sensing the carrier in this particular range, sensing the carrier in its range, it senses that the carrier has been busy at that moment, so that it should remain idle without transmitting any data to any other party, so that it is unnecessarily delaying its own transmission. It has been waiting for a long period of time until B completes the transmission with A. So that is the problem of the exposure terminal. So in this case, what happens is whenever B wants to avoid that particular exposure, that is unnecessary delay with the C terminal. Here, B whenever wants to transmit the information to the A, whenever wants to send the information to A, it has been sending the signal obviously as request to send, isn't it or not? So that whenever it is requesting the A, it has to, that is A has to in turn return back with the CTS, isn't it or not? So that the same RTS signal for which it is going to be sending with A, it is also been sent to the C. Okay. So the same RTS which is going to be sent by B to A while communicating from B to A, the same RTS is also been sending to the C, intimating that it is not bothering about the communication channel of the C, and it is going to be communicating with A and intimating that you are free to communicate with anybody now, even though my transmission range is get collided with your transmission range, but I am busy with some other communicating terminal, and your carrier channel is absolutely free, so that you can communicate with other parties without any delay and without any waiting moment. So by saying this RTS, C can identify that, okay, B is not using any carrier and B is not using any particular carrier which is colliding with C. Just B is going to be communicating with A, so that C is now free to communicate with any other part and it will just do it. In that way, you are going to be avoiding the exposure terminal also. So what the scheme is, multiple access with collision avoidance. In the both the cases, whatever may be the collision avoidance and whatever may be the unnecessary delay of all these things, what we discussed as the main problems of the wireless communication are being avoided in this, and at the same time multiple accessing is being possible. A and B are communicating, C also wants to communicate with other party, no problem. Both the three, I mean all the three can communicate with each other. We are having the multiple accessing with the three stations, what we are discussing in the example, and at the same time we are also avoiding the collision here. So this is the scheme, right? Coming to the polling, already discussed about this particular term in the various cases while performing with identifying the CSMA. That is, while doing with the CSMA, I discussed about this polling procedure. That is nothing but a particular station is going to be polling each and every time the corresponding transmission media. All the stations are not going to poll. Okay, this is a particular centralized scheme in which only one station is going to be polling and identifying the whether other station is being able to ready to get the data or not. If that particular master station identifies that the other slave stations are being able to get the data, then it is going to be allow it to transmit the data to it. And for that one, it is going to following the round robin fashion and the random picking fashion in order to poll a particular station or choose a particular station in order to send the data. Right. So if any one particular station is being busy with some other master station, then it has to wait for. It will be choosing another station in order to do. For example, I'll show you. What happens in the polling is, this is the sender side, say, and this is the receiver side. There are different of channels in the transmission media. Right? There are number of mobile stations or mobile users. Right? There are number of mobile users. So please listen carefully what happens with all the mechanisms, so that how widely and how popularly are going to using this mobile computing environment to accommodate much of number of users and multiple communication, multiple sending data via our mobile computing devices, whether it may be a laptop, iPad or iPod or whatever it is, your handy mobile. Okay. See, for example, from the sender side, if any mobile user wants to send the data to the receiver side mobile station, then among the one of the sender side mobile stations, on the side of this particular sender side, there will be a master station. There will be a master station which is going to polling the total transmission media, continuously to check that the carrier frequency that is to be used by our sender, to check that the carrier frequency that is used by our sender. If that particular carrier frequency is not free at that moment, in order to send by itself the data to the corresponding receiver mobile, then the master is going to be giving either any other alternative or keeping the sender to be remain calm or make it to be waiting for a moment. What happens here? The sender wants to send the information through this transmission media, so that he has to choose one of the carrier. If that particular carrier frequency is not idle at that moment, is being used by some other mobile stations, that is both the sender and the receiver mobile stations, by sensing this, who is going to be sensing? Master is going to be sensing that which carrier is free and which carrier is busy at that moment, to acknowledge the corresponding sender mobile station. So if it identifies that particular carrier is busy at that moment, then it will acknowledge just the corresponding sender mobile that you won't be able to communicate at that moment. Please wait for some time. Otherwise, it will itself choose some alternative, another channel in order to send it. In that case, the sender will not be give any acknowledgement. Simply, it will be shifting that particular sender's data to that particular station itself. Okay, that is nothing but internal or interhand of, that is nothing but the interhand of where the carrier frequency is going to be changing. Our own carrier frequency is busy at that moment. Other carrier frequency will be chosen by the master itself, and it will be sent to the sender itself. And coming to the receiver side, in the similar way, the receiver side is also going to be having some master. Okay, so other stations are being called as slaves, and the stations, I mean, the persons or the particular mobile stations or the channel which is going to be monitoring the status of the carrier frequencies of the masters. Both are being happening on both the sender and the receiver. Only one is going to be the master and other are going to be slaves. And the checking procedure and sensing of the carrier busyness on the side, on the both the sides, or the sender side or the mobile, what is called as receiver side, is called to be polling. Is called to be polling. Whenever it identifies a particular thing was higher or it is going to be idle, it will be get allocated for the transmission. Otherwise, it won't get. Okay, that is what happens in the corresponding polling procedure, right? This will be also useful for, even though it is going to be useful for the collision avoiding environment, but it is going to be giving only the fixed accessing, as a master is the ultimate controller. Why? Because the slaves will not have any controller until they are going to be getting the status of the master, right? So this is the procedure of a polling one. This is one of the scheme again. So what happens here, it is basically what happens in this particular polling procedure is the base station is going to be signaling the status every time to the satellite regarding the mobile terminals. The base station is going to be acknowledging the particular status of the mobile stations every time to the satellite station, which is going to use it with both the Cdma or also the FDMA. And the collision will be identified based upon the polling addresses, that is which stations are going to be trying at the same interval of time, so that they can be get collided. So how they has to be avoided, how the particular acknowledgement has to be done with the correct packets to the corresponding polling terminal, what is to be done, how the cycle has to be repeated among all the polling or the slave stations will be done by this particular randomly addressing polling. That is nothing but once a while, if one of the station has been chosen for using that particular carrier, again in the second cycle it won't be allowed to. Likewise, in a round robin, all the chances will be given to all the corresponding slave stations, but every time the control will be under the master itself. Okay, that will be the disadvantage of this polling procedure. And coming to the another one is inhibit sense multiple access. Inhibit sense multiple access. This scheme is used for packet data transmission service, packet data transmission service, which is mainly used for the cellular digital packet data. Okay, that is called as a cellular digital packet data, packet transmission, mainly in the AMPS. That is nothing but the advanced mobile phone systems. Advanced mobile phone systems are also called as the digital sense multiple access. Digital sense multiple access. What happens here is within this inhibit sensing means what you are going to be doing, what you are going to give you the multiple access with this inhibit sensing. Inhibit sensing is nothing but the base station itself. That is nothing but the base station itself is going to identifying the busy and idle status of the stations, or also the signals or the medium, whatever we can say. The base station will be going to be handling all these things. That is, no specific station or mobile station will be allocated as a master, or no specific sensing will be done by the mobile stations. That is, in up to now we have discussed that either the mobile station will be sensing the carrier, or it is going to be avoiding the collision, or a particular master station will be there which is going to be taking care of business of the transmission channel or business of the carrier, what is called as allocating the slots or sharing the slots. All these things are being done by the between the mobile stations, or there may be some master stations, right? But here what happens here is the base station will be taking care of all these things. It will be checking that what are all the mobile stations busy at that moment, what are all the mobile stations which are idle in it, and which channel has to be allocated to this particular mobile station, which is the need, so that the channel is been idle in position or busy in position, or it is being used by somebody else. So all this is being, that is whether the medium is busy or medium is idle in that point. All these things are being taken care by the corresponding base station itself. So how this could be done? That is nothing but again by getting the downlinking frequency itself, by getting the downlink frequencies which are sensed and updated and acknowledged by the base station to the satellites, which are sensed and updated by the base station to the satellites. The same what is called a status of the mobile stations, channels or medium or whatever it is will be get reflected back to the other mobile users who are requesting the free slot for transmission, who are requesting for the free slot for the transmission. That is nothing but without specific user intervention, and making some mobile station as a master one, and regulating and controlling all other. Simply the base station which is handling the receiving and sending the signals from the satellite and from the mobile stations, simply identifying that what are all the channels that are idle, what are all the channels which are busy, what are all the mobile stations which are in request mode, which are already serving, and which are remaining idle or not accessing any service. By identifying this, the same status will be get reflected back to the satellite. The same satellite, the same status will be get reflected down to the earth for all the mobile stations as a downlinking frequency. By identifying that, the users will retry for them. Either we are calling back again, that is whenever we are unable to get the network, we are trying or redialing or reconnecting, right? In that case, the downlinking is going to be rejecting our mobile call. The downlink frequency or the downlinking channel or downlinking carrier, which has to be received by our mobile, observing and sensing that line is busy, so that the service holders or the what is called as service operators are already recorded services are going to be alerting you that the network is not free at that moment, or the calls are not accepting by the mobile, or the mobile is out of station and mobile is switched off, or you are out of the network service area. All these are going to be done by this particular downlinking services, right? This is the inhibit what is called as sense of access. That is within the base station and between the mobile station itself, this is being done. Internally, it will be identified by the corresponding base station itself. This is called as a digital sense multiple access, mainly used in the advanced mobile phone systems, which is a analog system procedure, right? And next one is Cdma. Already you know about this Cdma. We discussed about this particular Cdma. All the users will be get allocated with the particular code characteristics. According to the coding itself, the users will be identified. The data transmission and data bits will be get identified. Okay, so the code division, the code is going to be dividing all the users among them. That is by having with the available number of the users, you are going to be coding those uses depending upon the number of bits we take. That is, for example, if you are having the 8 numbers in a combination, that is, you are going to communicate with the 8 numbers, obviously you'll be taking the 3 bits to code them. That is, who are the one among the 8 numbers. Otherwise, if there are only 4, obviously we'll take the 2 bits to code them. In that way, you will be identifying that how many number of people with which you are being communicating, or the particular channel is being accommodating how many number of users. Okay, so according to that particular thing, the users are being get coded with the corresponding binary digits. So according to that, only the transmission is being get separated, and all those are going to be transmitting without getting interference with each other, right? So having the particular coding processor itself, we shouldn't have the interference until and unless there will be some disturbance in the transmission media, they will be get erroneous. Otherwise, with the code division multiple access, we will be having the free accessing and also the pure accessing, right? Here, what happens here is each sender will be given a unique random number. Each sender will be given a unique random number, and sender's random number will be XORs with the signal. Okay, this number will be XORs with the signal value. The station will be, or the sender will be given an unique number, and that number will be get XORed. That is, you are going to be exclusive or doing the exclusive OR operation with the signal value that you want to send. That is, signal will also get dumped into the zeros and ones, and user is also given some bits. Okay, user also is given some random number which is in the form of bits, and also the signal will be also dumped into the form of ones and zeros. All these two, that is the sender's unique number and also the corresponding signal that we want to send, both are going to be get XORed with each other, so that that particular signal will be sent to the receiver. On the receiver side, again, the same thing has to be done. That exclusive operation has to be dumped on. The pseudo random number will be sent to the receiver. Using that particular pseudo random number, again, the receiver has to demultiplex or decode that particular value, right? So this has been done using, I mean, the receiver and the transmitter every time will be get tuned using this particular correlation function, right? So coming to the disadvantages of this particular thing is higher complexity of a receiver. There is nothing but you are not simply getting a plain value or a plain data from the sender side. The sender is going to be get XORed with his own unique number and also the signal that he is sending. So that on the receiver side, again, we have to do what sort of calculations we have to do. That is how we have to decode that particular signal in order to get the original value. That is the thing that is we have to start. Okay, he has going to be receiving the signal, right? All signals should have the same strength at the receiver. And another thing that is to be considered here is all the signals should have the same strength. Otherwise, if the strength is going to be getting deviated, obviously as you are coding the signals, the codes are going to be changed. If the signal is been fluctuating as you are coding the signals there, automatically the code is going to be changed while receiving to the receiver. That is the two, those are the two disadvantages of this using scheme. And coming to the advantages, all users are going to be using the same frequency. No need of planning. That is how which frequency they are being using and or which particular thing are going to be using, which band they are using. All these are not being bothered about. All are going to be the same frequency, and huge port space is given. Nearly 2 × 32 number of ports can be available for all the frequency bands and all the users that can be accommodated. And no interferences will be there as they are being perfectly coded. So until and unless if you are having any problem in coding, and until and unless the medium is going to be get erupted or corrupted, we will be having no interference among this particular code division multiple access of procedure of transmission data. And forward error correction, that is the FEC, what you are discussing with the Cdma, and also encryption procedures can be integrated. That is, error correction bits and encryption of the original data can be combinedly gone with the same frame. That is, occupation of the data for much of the memory. That is, memory taking will also be less when compared to the other schemes. What happens here is the advantages are all channels are using the same frequency. Huge code space is there for all the frequency accommodated users, and no interference will be there. No specific code interference will be there, and forward error correction and encryption procedures are integrated in the same frame. Coming to the disadvantage is nothing but on the receiver side, the receiver has to get struggle in order to decode the data. That is, whatever the sender is having the equipment of coding, the decoding equipment has to be get equipped by the receiver side, and all signals should have the same strength at the receiver. Why? Because until and unless they are being received at the same strength as they have been sent by the sender, obviously as you are going to code and decode the signals with ones and zeros, their values will be interchanged. Once they are being changed, obviously the data that you are being received will be changing over. See, here we have been given an example of some Cdma procedure, which we will discuss in the next class, which will give you the complete picture that how they are been coding the signal and the random number, and how they are doing the XORing the values, and how they are been reconstructing at the receiver side. Okay, and two mechanisms are there. There is soft handover and soft handoff, and then another one is the spread aloha. With this, we are going to be completing the corresponding what is called as Mac procedures and Mac motivation. That is, with that particular Mac motivation, how you are been implementing all these methodologies. In some cases, CSMA, in some cases, CDMA, in some cases, HDMA, in some cases, what is called a reservation aloha, slotted aloha, classical aloha, whatnot. Many number of schemes are there for us. How these schemes are implemented in the wireless LANs with the standard of 802.11 that can be discussed as a major part of the other major part of the second unit. Okay, so with the procedure of this, what is called as spread aloha, we are going to be completed with available schemes of accessing the data for multiple users. With the help of the Mac, you are going to be accessing all these schemes. That is, Mac can be implemented in conjunction with all these accessing schemes. So using in conjunction with all these schemes, Mac can also communicate in the wireless LANs. So how it is going to be done? So what the wireless LANs are been offering in order to what is called as accommodate these schemes into that particular wireless LANs with the standard of IEEE 802.11, which we can be discussing in the next class, right? It's already time, I think, over. I'm leaving the session, right? Please refer the topics until now regarding the Mac, motivation of the Mac for wireless transmission, so that from Monday onwards, you are going to get peeping into the particular topic called as IEEE 802.11 LAN, right? So once along with this fundamentals itself, we are about to know that how you are going to implementing these techniques in the wireless LAN of the version 802.11, right? Okay, I'm leaving the session. Have a good time.